Do Russian fighter jets give up speed to carry more weapons? This question comes up everywhere in aviation circles. The debate often creates more heat than light. Some say Russian jets are built to haul immense weapon loads at the cost of top-end performance. Others argue speed is a Russian hallmark. So let's move past claims and look at facts. We'll examine actual designs: MiG-31 Foxhound, Su-57 stealth fighter. We'll test the claim with clear examples. And basic aerospace principles. Facts, not guesses. At the core, trade-offs. No jet is best at everything. Designing is balancing competing needs. Want more speed? Reduce weight and drag. To link speed and firepower, start with flight basics. Every jet is governed by lift, weight, thrust, and drag. Lift keeps it flying. Weight pulls it down. Thrust pushes it forward. Drag holds it back. Constant speed needs thrust equal to drag. To accelerate, thrust must exceed drag. Adding weapons changes the balance in two ways. First, weight increases. More weight needs more lift, and that can add drag. Heavier mass takes more thrust to accelerate. Engines work harder, pushing a heavier jet. Physics is unforgiving. More weight, less performance headroom. Every missile, every bomb, every tank adds up. Second, external stores add massive parasitic drag. Most weapons hang on pylons under wings and along the fuselage. They disturb smooth airflow, creating big resistance. Drag acts like a constant brake. More thrust to maintain speed means more fuel burn. That's why specs cite a clean configuration. Clean, it can top Mach 2+. Loaded for cap, practical top speed drops. Weight hurts, drag hurts more. Mission turns a racer into a weapons platform. No single fighter excels at every role. Air-to-air needs differ from strike and recon. Air combat favors agility. Strike favors payload and range. Designers must prioritize. Some jets chase raw speed. Others haul heavy weapons. Main variables: speed, payload, range, maneuverability, stealth. Improving one costs another. An interceptor must get there fast. Lock targets quickly against bombers and cruise missiles. Speed and climb are paramount. Powerful engines, low-drag airframe, big radar, and long-range missiles. Dogfight agility is secondary. Sacrifice some agility and diversity for speed. A multi-role fighter must do both. Air-to-air and air-to-ground. Needs agility to survive, and capacity to carry many weapons, plus long combat radius. Bigger wing, more stations. More power to lift the load. Large internal fuel tanks. Top speed reduces with heavy load. Russia built both specialists and generalists. Fast interceptors and heavy strike platforms. Answer depends on the jet and mission. It's a deliberate trade space. The MiG-31 Foxhound is the pure interceptor distilled. Built to reach, see, and kill fast. Extreme speed and altitude to guard vast airspace. Design prioritizes speed and sensor reach. It doesn't trade speed for firepower. It integrates specific long-range weapons into a supersonic platform, a flying missile battery built to arrive first. Top speed exceeds Mach 2.8, driven by immense D30F6 turbofans, rapid acceleration to the stratosphere. Operational ceiling well above 60,000 feet. Steel and titanium handle heat and stress. Not a nimble dogfighter, by design. Its prey is bombers and cruise missiles. It trades agility for velocity. Missiles are semi-recessed under the fuselage to cut drag versus wing pylons. Maintains high supersonic speed when armed. Designers protected speed as the key attribute. Primary armament, R-33 and R-37M BVR missiles. Mission demanded both speed and reach. Built to carry heavy missiles at speed, it sacrifices low-speed agility and stealth for its singular goal. Result: devastating firepower with speed. Speed and firepower aren't always opposites. A specialized tool for a specialized job. The Su-57 tackles the dilemma with stealth. 5th gen features emphasize low drag and LO. Key: internal weapons bays. Carriage inside the fuselage keeps the jet clean. Benefit 1: stealth. Benefit 2: less drag. Designed to supercruise, low drag is essential. Internal carriage is critical to speed. Missiles tuck into main and side bays. In stealth mode, speed isn't sacrificed. Trade-off: limited bay volume and size. External stores add payload at drag and RCS cost. In contrast to the MiG-31, the Su-34 is a dedicated strike fighter, and the Su-35 is a multi-role air superiority jet. These prioritize firepower and range. They accept lower top speed when fully loaded, based on the robust flanker airframe, built to carry heavy loads far. Mission: deliver ordnance or patrol long. Su-34, side-by-side crew for strike work. Penetrates and hits precise targets. Carries up to roughly 8 tons across many stations. With tanks and weapons, speed is compromised, but performance remains respectable. Su-35, fast and agile when clean. Up to 12 to 14 hardpoints for cap loads. Stays up, engages multiple targets. Fully loaded, it won't set speed records, but balances endurance and firepower. Here, speed yields to combat persistence. For some missions, payload beats another 100 knots. They're still fast, just optimized differently. A deliberate more is better approach to firepower. Engines drive the equation. More thrust can offset payload penalties. Russian engines emphasize raw thrust. Allows speed even when heavy. Cost: fuel burn. Range falls fast. Pushing hard drains tanks quickly. Flankers carry lots of fuel internally to match Russia's geography and doctrine. Different paths to solve the same problems. US modern focus: stealth first. Internal bays preserve speed and low drag, but limit initial payload. Win the info fight, shoot first. Russia emphasizes payload and EW strength. Formidable brawlers and dense EW. Visible arsenals. Accepted drag penalties. Philosophies are converging with Su-57. Both sides mix stealth nodes with weapon trucks. Do Russian fighters sacrifice speed for firepower? There's no single answer. True and false depends on role and jet. The blanket claim is a myth. Choices and compromises define outcomes. MiG-31, speed and firepower complement each other. Su-57, internal carriage preserves speed, payload limited. Su-35, Su-34, accept speed penalties for massed weapons. Air dominance, strike endurance, different needs. All fighters face the same physics. Russia built some of the fastest ever, and some of the heaviest armed. The mission drives the machine. External stores always add drag, full stop. Different tools for different jobs. Some try to master both, within limits. Verdict: it depends on role, load, and design. For more fact-driven breakdowns, stay tuned, fly smart, understand the trade-offs.